All right. So that's going to be your new link. So you may want to hit refresh. And so we're just kind of reviewing at the moment here the newish, what is it? The newish. Let's see if our audio levels are good. They're good. I sent people a new link, and we should be fine. All right. So we're reviewing heading and bearing, right? This is where we left off from last time, heading and bearing. What we added new today with our heading and bearing is the direction of due north, due south. Due north is straight up and down. Due south is straight down. Due east is to the right, and then due west is to the left. So we're doing some, some navigation here. It's just a way of describing direction. All right. So describing direction, and I'll check on my end as well. All right. So, okay. Yeah, it's going there. Okay, folks, we're good. So, does anybody have any questions on that kind of stuff here? You guys clear with a compass? Up is due north, down is due south, to the right is due east, to the left is due west. And we generally read it as north, angle east or west, south, and angle east or west. You just read it left to right as you're reading a book. And then you say, okay, well, how do we use this, or why do we use this? Well, we start to get to some kind of interesting applications here, right? This is kind of where we left off, ladies and gentlemen. And these are personally some of my favorite applications because, it's a very realistic situation. And so let's go through and let's read this, right? These are word problems. I did start to say that I did send you guys some extra credit. Is that true? Right? So I did want to go to the browser, talk about that. If you go to the assignment portion in the browser now, if you guys notice, I have been giving you, hopefully you're connected to Canvas like I've asked. And so I have been giving some people to keep them honest on some extra credit. What do I mean by keeping people honest? Homework on right triangles, area and arc length, law sines, law cosines, these kind of things. Stuff that you should be doing for your homework, they're assigned in your homework, but this is kind of extra credit. So if this is going to be a motivation for you to try to do that, then okay, let's see how well that works, if that's any motivation at all. For some people it is, for some people maybe not, but all right. So let's look at a navigation question, okay, you guys. So they're saying 2 boats leave the same port at the same time. All right, so 2 boats are leaving the same port at the same time. And let me let you guys know what that means here. Okay, this is where that port is. That's like the starting point. So here, 2 boats leave the same port at the same time. Now, one travels at a speed of 40 miles per hour in the direction of north 50 degrees east. So if I said to you guys, hey, what boat is that, north 50 east? Well, this is what they're talking about. Is that right? Let's do a little arrow here. So how we read this is really in relation to that first boat, north 50 degrees east. Now, I'm going to call that, I don't know, A, because what's the distance formula? Do you guys remember last week? Your distance formula from beginning algebra? Rate times time. So if I call that distance A, this is the rate is 40 miles per hour, and we need a time value. I bet it's going to come up. But when I read this, that's what I'm seeing here myself, okay? So there's your first boat. And then the other, you say, what's the other? There's two boats. So the other travels at what? 28 miles per hour in this direction of south 80, south, and there's a typo. South what? 80 degrees. That's going to be 80. That's the southeast direction. We're going to call that B, okay, for the second leg. So that's B. We'll put that B here. So then B will be what? 28 times our time. We don't know what time is yet. But notice what the question is, right? What are they asking here? How far apart are the two boats after 3 hours? So in other words, they're asking for this distance here. And, you know, I'm going to call that D, but I'm going to say that's a different D than what you see here. Okay, this is your standard distance formula. Distance is rate times time. So that's a different D. I'm going to say don't even look at that D anymore. But we know what time is now. What's our time? Is our time 3 hours? So this will be times 3, and this will be times 3. So what we know is that A here, if we just move this now, A is going to be what? What's our A value? 120, is that right? I don't need my calculator for that. So that's 120 miles. That's A. Okay. Now, what is B going to be? Do you guys know what B is? Is that 84? Good. We don't need our calculator for everything, do we? So that'll be 84. We're going to have to get out the calculator eventually, though. 84 miles. And so they want to know how far apart are the boats after 3 hours. That's the D part. Okay? And yes, they gave us some time. So, ladies and gentlemen, what you need here to answer this question is an angle. And I make the claim you guys can get that angle. Right? Let me get out my calculator. How do I know you guys can get that angle? What angle is that? As I wake up the TI, what angle is that going to be? Do you guys know? Is that a straight line? So what does a straight line have to measure? Wish I had my sound effects. What does that straight line have to measure? Do you guys know? How do you get that angle? Uh-oh. Huh? A straight line should measure 180. Is that true? So what I'm saying here is you take 180 minus the 50. This is 50 degrees. And then minus the other 80 degrees. And what's 180? This is going to be what then? This is going to be 50 degrees? Is that right? It looks like this angle is 50 degrees. Because 180 minus 50 is 130, minus an 80 will be another 50. So this arithmetic here is 50 degrees. That's what we just determined here. That's the missing angle. Well, yeah, why is it? The point is, why is it 180? Do you guys remember? This angle, and this angle form a straight line. So the sum of those three angles needs to be what? 180. Now, another thing I want to mention to you guys is this. What are you going to use to find the distance? Is this law of sines or law of cosines? I wish I had my sound effects. Law of sines, law of cosines. What do you guys think? Anybody? Why is it law of cosines? There's a reason. No. Because we have what? Side. How did that happen? Side, angle, side. And we're trying to find what? The distance, this D here, that's opposite your what? 50 degrees. And we already know A is 120 and B is 84. So we have a side angle side situation. This is the known angle, the known side, and this is the known other side. So that should tell you this is law of what? Cosines, ladies and gentlemen. That's a law of cosines question. Okay, you're with me on that? Law of cosines? All righty. And that's why I gave you guys that work to do. Right? That's why I did that. Because if you try to do it just the night before, what's going to happen? You're going to remember. So imagine if the Dodgers just practiced the night before a game, or the Lakers. Huh? The what? I don't know. I wouldn't want to watch. I'd be like, okay. Anyway, law of cosines. Here we go. D squared equals what? You guys remember? 120 squared plus what? 84 squared minus 2 times 120 times 84. Cosine of that 50 degrees. So like in my mind, again, there's very little I really memorize. And I want to make sure you guys see my point here. That with law of cosines, it kind of resembles a bit of what? Pythagorean theorem. It's not really, though, the Pythagorean theorem. And so now D is the square root of all this. And let me do this. So here we go. Let's get out the calculator. Where are you, calculator? Anyway, it's really... Here we go. All right, you guys ready to enter this? Here we go. Second square root, 120 squared, plus what? 84 squared minus 2 times 120 times 84 times cosine of 50 degrees. Close that. Ladies and gentlemen, what do you get? What's your distance? 92 point what? 2, and is that miles, I guess? I think that was in miles, right? So there's your distance D. Easy peasy lemon squeezy. 92.2 miles, and that goes right up in here. That's your distance here, 92.2. We're going to go out to the nearest tenths. We're going to be a little bit more accurate. Okay, 92.2 miles. This was a side angle side scenario, and there you go. And that's it. There it is, let you guys. Easy peasy lemon squeezy. Law of cosines question. And then notice what they did. They just integrated language of bearing and heading, and that's it. That was the new wrinkle. Language of, how to get those angles there. So these are just classic kind of questions in a trig course. This is why you study law of sines, law of cosines, in all honesty. This is one. If you don't do applications, it's like, why are you studying these kind of things, right? And the applications, even though they have words, they're not too bad. Okay, they're not too bad. So take a look at this one here. This is exactly the same. This is the same kind of question. Okay, navigation. 2 boats leave the same port at the same time. It's the same. And again, this is where the port is, as you guys know. It's right there at the origin. Even though you say, well, that's not really not an origin, that's a compass. Well, kind of. So there's your port, right? You're leaving the same port at the same time. One travels at a speed of 40 miles per hour in the direction of north 50 east again. Oh, okay. North 50 east. So that is northeast. There's your 50. We'll call that boat A again. So A will be 40. Notice it's going to be the same thing. That's 120. And it's in miles. Okay? Because they're telling you here, looks like when I did this, I pretty much kept that one the same. And the one I changed was some of the new language. The other travels 28 miles per hour in the direction due south. And, oh, what happened? What happened? Where'd you go? Weird. 28 MPA miles per hour due south. So the one's down here. That's what I wanted to show people here. Okay? So this is B now. And B will be, oh, it was 28 times 3. So that's 84. So, okay. So, you know, we're doing the same kind of thing. So there's 84. I'm going to move this here. All I'm changing was the direction. So A is 120 and B, and that's in miles, is 84. And I know what they're going to ask, how far apart are the boats? That 3-hour difference again, it's just boat B is in a different direction now. Okay, there's your boat D. They're going to ask, not boat D, sorry. They want to ask, that's the distance D, how far apart now? However, you need an angle right in here, don't you? Well, I don't, is it a right angle? Be careful. It's not a right angle. It's not a 90-degree angle. How do we get the angle of that triangle? Now, you might say, what triangle? I know my colors are the legs here. One leg is orange, one is green, and the hypotenuse, it's not even a hypotenuse anymore. Just the longest side is purple. So you're looking at a triangle. So in other words, anybody know, how do I get that angle? How do you get this angle? What do you guys notice? Again, don't you have this angle and this angle form a straight angle? So what is that? 180 minus now what? 50 degrees. What does that give you? 130. So this angle now, and that's really the essence that I wanted to do for people, is illustrate to them that by changing one direction of one boat, going simply due south, to compare and contrast here. You know, with the prior example. So now that angle that you're going to use for, is this law of cosines again? How do you guys know this might be law of cosines? You have side, angle, side. Isn't that law of cosines? So we should have called this really a law of cosine application. What's law of cosines? Again, law of cosines, ladies and gentlemen. This is going to be now what? D squared again will be 120 squared plus 84 squared minus 2 times 120 times 84 times the cosine now. What's the new angle? 130 of 130 degrees right in here. See my point? What's your D? Square root of all these things. So this is just like the last one. It's just that your direction gave you a different angle. So now let's use log cosines in our calculator again. Second square root 120 squared plus 84 squared minus 2 times 120 times 84 times cosine of, what is that? 130 degrees. What do you guys get for that distance? What's that going to be? 185.5 what? Miles. There's D. 185.5 miles. That's your distance. And there it is. Law of what? Cosine. So that's why you guys worked on those law of cosines, homework and extra credit. That's why it was there. And that ends here to some degree with my ultimate favorite setting. Okay, ultimate favorite navigation. So these are all navigation kind of questions, law of cosine applications. And let's look at the last one there here, right, as an example so you guys can see this here. Because aren't they similar to some of the book questions? Do you guys notice that? Are they similar to your book questions? That's the whole idea. Oh my God, is that yelling? Let's close the door. You know what movie I seen this weekend? It's an old movie, 2014. I didn't know. I was watching it with my daughter, Whiplash. Anybody ever seen that movie? Oh my God. If you ever guys want to watch a movie, that's a good movie. It won 3 Academy Awards. It came out in 2014, Whiplash. Huh? It used to be what? Young. When you were young? Well, some of you guys were born in 2014. Is that right? No? Who's seen that movie? Why am I bringing it up? No. Reminds me of some of the noise that's come in this room in the movie Whiplash. I used to be in the Marines, ladies and gentlemen. I went to Marine Officer Candidate School. So I was talking to my daughter about that movie. If you've seen it, you understand a little bit of what I'm talking about. So reminds me of that, you know, a little bit of that stuff. Whew. Yeah, look it up and watch it sometime, you know. You guys get a chance. It's probably on Netflix or something. I don't remember where Man, that was a movie for you. A fisherman leaves the home port and travels in the direction north 70 degrees west for 40 miles. So now, should we guys have you guys try something like this maybe? Give you guys some time to try it? I just want to say a few things here, right? Notice what's going on. The fisherman leaves a home port. And I guess they labeled the home port. Where's your home port? Here, you guys see that? So let me just read through it to verify if there's any typos, because I don't remember if there are, but fisherman leaves his home port, there you go, and travels north 70 degrees west for 40 miles. So there's north 70 degrees west. And you want to know what's nice about this question? It's not a distance equals rate times time. What do they give you guys here? They gave you the distance now. Is that right? That measures 40. There you go. And reaches a location called Egg Island. You go, okay, where's Egg Island? This is what they're talking about. So all of that here is referring to that first sentence, okay? Does that make any sense to you guys as you read that there, that first part? And then what happens next? What does the fisherman do? The next day, he travels how? North 65 east for 60 miles. There it is. And that is north. Is that northeast? Yeah, that's in the northeast direction. Okay, so there is no typo here so far. Okay. And then reaching what? Forest Island. All right. Easy peasy lemon squeezy. So far, so good. So that's in green. Reaching Forest Island. Find the distance between Fisherman's Home Port and Forest Island. Okay. So what I'm going to say to you guys is this: Forest Island, Home Port. That is D. So this is question A. There's D. I'm going to give you guys some time here for this. See if you guys can figure this out. Okay? So let me give you guys some time. We're going to get out the clock. And let's see if you can answer that kind of question. You guys may need. And if you finish, then go to question B, find the bearing back home. How do you get back home? Okay. So I'm going to give you guys some time for this question here. See if you can get D. All right. There you go. Let's do that. All right, ladies and gentlemen, let's try this out, okay? Now, notice here, based on the two examples we already did, if you had that angle, you would have what? Side, angle, side, and log cosines would apply. You're done. Is that right? You guys see my point? If you had that angle, I'm going to say to you guys, well, you can get that angle. Does anybody know what that angle is? What angle is that? You might say, Mr. Judge, in order to get that angle, I need to know what this angle is. And I have a straight line. And then I could deduce that angle. Is that true? You guys with me on that? And then I'm going to say to you guys, well, you know what that angle is, because it's based on knowing that angle. What angle is that? Does anybody know? How do we get that angle? Anybody know how we get that angle? Well, is that 70? So you're saying this, oops. You're saying this measures what? 70 degrees. Why would you say that measures 70? Because I would say to you it does measure 70. How do you know it measures 70? Let me do something like this for the moment, okay? I'm going to erase this here. Maybe it's easier to see. The claim is this measures 70. You know what I'm going to do? Let me see if I can do that here. I'm going to move this line. And this is called what? L1. Then I'm going to create this line. If it lets me. Yeah, sorry. I have to do it this way. See if I can. Okay. I'm going to call this line L2. And then see if I can change the angle on that. I don't know if I can. So I'm going to have to do this instead. See if I can move this. There we go. Sort of. And this line is L. Do you guys know what you're really looking at? You see this here? If this is 70 degrees, that means this has to be what? 70 degrees. You guys okay with that? Because you have a transversal, don't you? Because L1 is parallel to what? L2. Didn't we work with those transversals? Okay, do you guys remember that first week we did transversals? That's why we did it. That's why. So there's your transversals, ladies and gentlemen. So that's 70. So what that means now is to get the purple angle here. This is 180 minus 65. minus the 70-degree angle you just found. And what's that going to give you? Anybody know what angle that is going to be? Is it 45 degrees? All right, good job. So that angle is 45 degrees. Okay, 45-degree angle. I'm going to erase all that so that we can take a good look. And guess what? I'm going to erase all this now. Just so you guys know, I'm going to erase it. Yes, you have a video, but you created a transversal here. Because now, ladies and gentlemen, you know, yes, you can get that distance d now. Okay, so now it is law of cosines because you have side angle side. So that is the key, ladies and gentlemen, to transversal. So at this point now, you can say, okay, what's my d squared now? So then d squared becomes 60 squared, right, plus that 40 squared, minus 2 times 60 times 40 times cosine 45 degrees, which means d will become the square root of all of that. So we're going to get that distance down. And that's how you do it, ladies and gentlemen. You go back to the world of transversals that we worked on. So let's go to the TI and you say, okay, this is second square root now. This is going to be what? 60 squared, okay, plus 40 squared minus 2 times 60 times 40 times cosine 45 degrees. Now, ladies and gentlemen, what's your distance? That's about 42.5 miles. Because we're going to go to the nearest tens position. So 42.5 miles. There you guys go. What do you guys think? Pretty good? It's 42.5 miles. So question A just found how far these locations are from one another. Find the distance between Fisherman's Homeport and Forest Island. Transversals. So keep that in mind that transversals are at play here. Okay, because the next question is just as what? Just as important, because now, what's this question going to be? What are they saying now? I'm going to keep that in blue. Find the bearing from Forest Island back to Fisherman's Homeport. So what they're saying to you is, how do you get back home? So if you are here at Forest Island and you're trying to navigate to get back home to what? The home port. Okay, how do you get back home, ladies and gentlemen? What's the heading and bearing? How do you get home? That's what they want to know. How, you got to get back home now. So, you know, you could be traveling in a boat. You could be in an airplane. It doesn't matter. This is a navigation situation. How do you get back home? Here's what I say to you guys. What direction do you go? You're going south what? Southeast. Is that true? So remember the definition. South, some angle theta east. Where is theta? Theta's right here. Is that true? So if you can get theta, you can get back home. So how do you get theta? Okay. And then you got to get theta now. So this is your new challenge here. This is challenge today, navigation questions. Big challenge. I'm going to give you guys a hint. You guys want a hint? Think of a transversal. But only this time, let me do it this way here. Okay? That theta is the same as what theta? If this is a line here, if this is L1, and this is L2, let me see if I can do that there. Maybe barely. Okay. This is some L. That theta is the same as this theta. Is that true? Isn't that a transversal there? That theta is the same. Is that right? So if you can do this, ladies and gentlemen, if you can tell me this angle right here, call this H. What do you know? Can you get this angle here? I say you can. If you get angle H, what's the relationship between H and theta? Tell me if you guys agree. Isn't it true that H plus theta is 70 degrees? And that 70-degree angle, H plus theta? So then that means theta has to be 70 degrees minus H. So if you can get angle H, ladies and gentlemen, because you're looking for theta, if we can get H, and H is in blue, you're done. H is right here. That's the H for home port. How do you guys get H? Law of what? So another law of cosines question. So you're going to get H. What do you guys think of? Why do I say law of cosines? Because now, if I erase this, I'm going to erase this here now. Do you have any space? Oh, no, we have it down here. This is side, side, side. Is that true? You now have 3 angles. Do we? Well, I don't know. No, we got, sorry, let me apologize. 3 sides. This is not angle, 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 side, side, side. So in other words, I can get H this way because I have a side, side, side situation. So what is that? 60, 40. So let me do something like this. This is 60, right? 40, 42.5. This is my point. Something like 60, 40, what? 42.5. There's my H. So if I can get that, I'm home free. So you might say, well, how do we get that? Well, this means by law of cosines, 60 squared is 40 squared, 42.5 squared minus 2 times 40 times 42.5. Cosine of that angle, 45 degrees, right? Because we knew this is 45 degrees already. I'm sorry. Oops, not cosine 45. Sorry, cosine H. I apologize here. That's H. This is what we're looking for, right in here. I think we colored it blue. So let's go back. That's what we're looking for here. We're looking for this angle right in here. This is the H we're talking about. If we get H, H plus theta is 70. We're looking at that picture. Law of cosines. So now law of cosines comes in and says, okay, solve for cosine H. right? Cosine h will be, what is cosine h? Do you guys remember? Maybe you want to see every detail. Translate. Move the term to 40, 42.5. Cosine of h is 40 squared, 42.5 squared, minus now 60 squared. Cosine h becomes 40 squared, 42.5 squared, minus 60 squared, 2, 40, 42.5. What is h going to become now? Inverse cosine. Okay, so we can get h now, and with the ti. So here we go, ti. Let's get that. So now we're going to clear that out. I'm going to say, okay, second inverse cosine. Remember, we did double parentheses so that the numerator was 40 squared plus 42.5 squared minus the 60 squared. Close that, divided by 2 times 40 times 42.5. Close that, double parentheses. And what did you guys get here? What is h? 93 point what? Is that 93.3 degrees? Okay, double check. Double check here. 93.3 degrees. Okay. And then something is bothering me here. What's the problem? Uh-oh. Anybody see a problem here with this? Yeah, what's the problem? Didn't we say theta is going to be what? Let's go back here. So this is, we just found h. That's supposed to be what, 93.3 degrees? Is that right? So 60, 40, 42.5. And so I see the angle theta being here. Theta. So there's theta. Looks like that should be okay, right? So the whole thing was supposed to be 70 degrees, it looks like, right? Interesting. 60, 40, 42.5. Let's double check to see if we did everything okay. Okay. Nope. Do you guys want to double check that? Let's double check this. See if we wrote everything down. 60, 40, 42.5. We need that h, right? So what is law of what? 60 squared is 40 squared plus 42 minus 2 times 40 times 42.5 cosine h. 2, 40, 42.5 cosine h would be 40 plus 42.5 minus 60 squared. So then 40 squared, 42.5 minus 60 squared, 2 times 40 times 42.5. H will be inverse cosine of all of that. So let's double check. All right, let's try that again, just in case. Second inverse cosine, parentheses, 40. Let's look at the calculator so you guys can see that here. 40 what squared plus 42.5 what squared. Okay. Minus 60 what squared. Close that, divided by 2 times 40 times 42.5. We're going to close that twice. See what happens. Okay. 93.3 degrees. So let's double check. Let's double check the whole situation here. Let's erase that. So h plus theta should be 70. Is that true? Do you guys see that there? We're looking at this. H plus this angle theta should be that 70 degrees. Let's read the first sentence again. North 70 degrees west for 40 miles. Home port north west. So northwest. So that should be 70. Yeah, we're looking at this right here. It should be 70. So we travel northwest 70. So if we find angle H, that should not be what? That has to be smaller than 70 there. So what's the deal? How about I do this? Let me look at this here really quick here. Okay, so this is going to be 45 degrees. Is that true? All right. Let's figure out what's going on here. I'm going to do this here. That doesn't make sense. You guys agree? Inconsistent. All right. Where do you think I'm going to go headed with this then? Tell me if you guys agree with this. Sine h over 60 should be sine of what? 45. Is that true? Over 42.5. So, by law of sines, cross multiplication, we know sine h needs to be 60 times sine 45 over 42.5. So, sine h now is going to be what we get here. So, let's use our TI. Let's see what we get. 60 sine 45 divided by 42.5. Okay. Now, this is going to be 0.998. So remember what we do. We have to find the inverse of this. So inverse sine of point what? 998. Close that, and what do you get? H is about 86.4 degrees. However, if we go back to the iPad, right? However, isn't that H1? What is H2? How do you get the second H value? You guys remember? It should be 180, right? Minus what? 86.4 degrees. Do you guys remember that? And so 180 minus this H. That's the 90. That's going to be the 90 what? That was 93.6 degrees. Okay? And what did we get for law of cosines? Do you guys remember? Well, I think it's up there. 93 point, well, it's slightly off, 93 point something degrees. Now, let's note here. Which one makes sense? Neither. But what makes sense in terms of law of cosines? I think they both make sense. There's two triangles, right? So anyway, we might have to find, there might be something that we're looking at here that's not correct. I doubt it, though. It looks like it's okay. Looks like it's okay to me. That's theta. This is theta here, but I'm going to have to double check. We'll have to take a look at this. Maybe if you guys can take a look at it tonight, maybe you find an error. I don't think there's an error, but I'm going to have to take a look at this situation. Anyway, find your theta. It looks like theta plus 70. I'm sorry, theta plus H should be 70 degrees. Double check. Is that true? You guys see my point? Anyway, okay. Well, we'll take a look, and we'll see you guys when? Tomorrow.